All right, let's do part A here. How much time elapse? Got a marker going here. We need to know time. We know a couple of things. We know that's acceleration. This car is going that fast. The 50 kilometer per hour zone probably doesn't matter. And we want to know how much time elapsed before the motorcycle is moving at as fast as the car. Well, a couple things we have to assume here. The motorcycle starts at 0. So I think we can use A equals change in V to get T. If I want T all by itself, it would be change in V over A. My change in V from 0 to 80 is 80 kilometers per hour. Now, we've got an issue here because kilometers per hour and meters per second squared are not the same unit, so we have to convert. Everybody say boo, boo. All right, so I'm going to take 80 kilometers per hour. I'll get rid of kilometers. 1 kilometer is 1,000 meters. And then I need to get rid of hours. 1 hour is 3,600 seconds. So hours is gone, kilometers. I'm after meters per second. That matches my acceleration. I'm going to pop this into my calculator. And I'm going to get 22.2 meters per second. So my change in velocity is 22.2. That's a 2, believe it or not. 22.2 meters per second divided by my acceleration of 8 meters per second squared. And I'm just left that number in my calculator. Divide by 8. I'm going to get 2.7 seconds. Okay, part 1's done, or part A. Everybody say, yay! Yay! All right, let's do part B here. A couple of things here. Remember the motorcycle is going 22.2 meters per second, and the time it took to get to that speed equaled 2.7. We could go 2.8, 2.77, I'll leave it, I don't care. 2.77 seconds. 3 significant figures seems okay. All right, so we need to find how far the motorcycle went, which is constant velocity. Said the car was traveling at a steady 80 kilometers per hour, which now we know is 22. So let's find the distance. Displacement equals velocity times time. The velocity was that same 22.2 meters per second in this 2.7 seconds. And I'm going to get about 60. I'm going to round that up to 60 meters. It was 59.94. I rounded it up to 60. 60 meters. Now, we have to find out how far. Now, the motorcycle's accelerating, so we can't use that. This is the car. The car went 60 meters. We need to find out how far the motorcycle, the police, went in that same amount of time. So I believe that is, since he started from rest and we don't care where 0 is, this just turns into 1/2 AT squared. So 0.5, the acceleration was 8 meters per second squared. And in this 2.7 seconds, how far did he go? We've got to square that. 2.7 seconds, 2.7 squared times 8 times 0.5. He went 29.16. I'll go 29.2 meters. All right, so this was the car. The car was, the car was 60 meters in front of when this whole incident started. This was the motorcycle. Was 29.2. So the distance between the two. That's all I'm going to do. I'm going to go 60 meters minus 29.2. It's on, what is it, 30.8, right? If I'm doing this right on a Sunday morning. 30.8 meters. That's how far was between them. That's part B. Woo woo, woo woo.